This is section 4.5. It is completing the square. So if you remember, we have 5 methods of how to solve a quadratic. We've now learned graphing method, factoring method, and the square root method, and the quadratic formula. So this is our 5th and final method of how to solve a quadratic. So when you're choosing between those 5 options, graphing method, we typically don't use graphing method as a choice unless, of course, the direction said so, or if a graph was already provided for you. It's very time consuming. So after that, you think about either doing the square root method or factoring method. Those are quick methods. However, those always can't be used. Square root method is not always possible. Factoring method is not always possible. So when those methods are not possible, right? Can't factor, can't square root. What you're going to use is either completing the square or quadratic formula, right? So if you can't square root, if you can't factor, you're going to choose to use one of these. Either one of these would work. These 2 methods in red, completing the square, quadratic formula, they always work to solve a quadratic. So when in doubt, you can use these 2 methods, no matter what. However, completing the square, not always the prettiest method. So we're going to do 2 examples, and then we'll talk about when completing the square would be like, ooh, I might want to stay away from that method for this problem. But it does always work, just not always pretty, okay? So here we go. Here's an example, number 1, of a problem where you can't square root it, and the reason I can't square root it is because it has this x in the problem, and it's not factorable. Even just by checking really quickly, this has a 1x squared, right? What multiplies to make -3 and adds to make 10? Not possible, right? So we can't use those 2 methods. I'm not going to do quadratic formula just because we already learned that. So now we're going to do completing the square. So make this example 1 in your notes, and I'm going to give you 4 steps of how to solve completing the square. Step number 1, you have to set up the equation into this format. 1x squared plus bx equals c. And I put the 1 there on purpose to really emphasize the point. It has to be 1x squared, not 2x squared, not 3x squared, not 4x squared, 1x squared, all right? So in this example, that's already 1x squared, so that's a good sign. We'll talk about what happens when it's not in the next example. And we have to move that c value over to the other side. So to set this problem up, all I'm going to do is move the 3 to the other side, and I'm going to leave a space where the 3 was. Because in that space is where I'm going to complete the square, right? So I'm going to add something to both sides. I'm going to do it in pink. I'm allowed to do this pink step because as long as you add the same thing to both sides, mathematically, you're allowed to do that. What I'm going to add to both sides is b divided by 2 squared. So I'm going to take my b value, which in this case is 10. I'm going to divide it by 2. So 10 divided by 2 is 5, and then square that. So I'm going to add 25 to both sides. When I do this, me personally, I write it 2 different ways. On the right-hand side, I write it as 25, right? Plus 25. But on the left-hand side, I write it as 5 squared. And I'll tell you why. In the next step, I'm going to factor, okay? And the reason why this is called completing the square is because this trinomial over here, x squared plus 10x plus 25, it's going to be a perfect square trinomial. I think I've used that term with you before. A perfect square trinomial is something like x minus 3 squared. That's a perfect square trinomial. Or x plus 9 squared. That's a perfect square trinomial. So when you complete the square, you're trying to find this pink number, which in this case was 25. You're trying to find this pink number that will complete the perfect square trinomial, right? What number goes there that creates a perfect square trinomial? And so b divided by 2 squared every time completes the square. So every single time on this left-hand side, you're going to now factor x squared plus 10x plus 25. And every single time, it's going to factor to a perfect square trinomial, something x plus or minus a number squared. And the trick is, all right, so every time that's going to happen, the trick is that you take that number that's in the pink parentheses. So in this case, 5. So plus 5. The sign that's in the middle here, let me grab my highlighter. The sign that's in the middle here, plus, it will always match the middle sign. So you'll see in the next example, if this was minus 10x, I would have written in pink negative 5 squared. And so then you just take that same sign, but it always matches the middle sign. That's a good double check. Okay? So that's why I wrote that in pink, x plus 5 squared, because now this 5 is this 5 every time that trick works. If you write the left side like this down here, that's fine. But then when you go to write your perfect square trinomial, it takes a little bit more thinking. Okay. On the right-hand side, I'm just going to add 3 plus 25 is 28. And now what you've done is you've changed this problem into a square, we did factoring, sorry. You changed this problem into a square root method problem. So from this step, you are going to solve using the square root method. All right? So from here, I'm going to do square root. Left-hand side becomes x plus 5, plus or minus showed up, and then I have the square root of 28. So I'm going to move that plus 5 over to the other side, so it becomes negative 5, plus or minus, and the square root of 28 is 2 root 7. You got two answers, negative 5 plus 2 root 7, negative 5 minus 2 root 7. And this is the completing the square method. All right, so example number 2, square root method. We're going to follow those same 4 steps, but this time the problem's different because it's a 3x squared. And remember, step 1 said it has to be 1x squared. So no matter what, on that step, if you have a number in front of x squared, no matter what, whether it divides evenly or not, you need to divide by whatever that number is. So even if it was, in this case, like a 4x squared, and so 4 doesn't go evenly into 6 and 12, you still have to do it, which is one of the reasons why this problem could get very messy. So this would become x squared minus 2x plus 4 equals 0. So luckily for us, the 3 divided evenly into everything. I'm going to move my 4 over to the other side and leave a space to complete the square. So now I have to fill in these pink gaps with a number. B over 2 squared. So B is negative 2. So I'm going to do negative 2 divided by 2 squared. Right, that's my little thought off to the side here, which is negative 1 squared. I like to write it like that. On the right-hand side, negative 1 squared is just regular old plus 1. The reason I liked to do this on the left-hand side was because now when I go to factor, it's x. I use the same sign as both the middle term, the negative 2x, and the same sign as my negative 1 in the pink parentheses. And I use the same number that's in the pink parentheses. Squared. All right, that's a perfect square trinomial. On the right-hand side, negative 4 plus 1 is negative 3. Now I've turned it into square root method. So I'm going to square root both sides, plus or minus the square root of negative 3. Well, that's an imaginary answer. I root 3. Add the 1 over to the other side. Make sure my answer is in standard form because it's a complex number. And that's my final answer. Now, when you have to pick a method, you've got 4 choices, right? We're assuming graphing method is not on the table. what I would do is when you have, and this is going to happen on the homework assignment, you have 4 problems and you have to use a method for each one. Method choice number 1, easiest to identify, is the square root method. So for example, if I had something like 3x plus 5 squared equals negative 24, that would be a square root method problem because I've got this quantity squared. Or maybe I had something like, 4x squared equals 16, right? Then I would do square root method because it just has an x squared in the problem. If I can't use square root method, the next thing I would check is factoring method, right? Now, factoring method, how do you know if you can do it or not? Some people are skilled enough just to see the factoring right away. There is another trick. If you find the discriminant of the quadratic, right, which is b squared minus 4ac, if that discriminant is a positive perfect square, positive perfect square, then that problem is factorable. So if your discriminant is 25, it's factorable. If your discriminant is 36, it's factorable. If your discriminant is 9, it's factorable, right? Positive perfect squares, it's factorable. Other than that, it's prime. So that might help you in choosing a method. Choices 3 and 4 comes down to completing the square quadratic formula. Again, both of these always work. But completing the square can be yucky, right? Why could completing the square be yucky, right? How could this problem be like a yucky problem? Well, if this 3 doesn't divide evenly into everything, right? Let's just pretend for a second that this was like an 8 here, right? Ugh, gross. That would not be fun. The other way that completing the square would not be fun is if the b value is a fraction, right? If the b value, I'm sorry, not a fraction, if the b value is odd. If the b value is odd, when you go to do b divided by 2 squared, right, then you're going to have a fraction that you're adding to both sides. It's just yucky. Is it possible? Yes, of course, just yucky. So in that case, you might want to pick quadratic formula. So you would pick completing the square if you've got a nice even b value, right? Then that might be the one that you choose for that. But really, these 2 methods, it's like a flip of the coin most of the time. So what we're going to do is just try a few more examples. I'm not going to teach through them necessarily, so go ahead and try numbers 3 and 4 on your own. Pause the video and try them, and then I'm going to put up the answers. All right, so on these 2 problems, here are your answers. Okay, some things to point out. The directions for number 3 said find the zeros, right? Remember that means that we're setting the y value equal to 0, right? So if it really bothers you, it does bother me, right? I would turn this around when I'm solving it. When you're completing the square, you're adding 9 to both sides, right? 3 squared plus 9, that would be your completing the square. This factors, 17, square root method, and you get down to this. On number 4, make sure you divide by 3 first on both sides. Yes, it didn't go evenly into the 16. I'm just going to leave it as negative 16 over 3. It's going to be okay, guys. It's going to be okay. So we would add negative 2 squared to this space, and we would add 4 to this space, right? I'm adding 4 on both sides. On the left-hand side, this factors to x minus 2 squared. On the right-hand side, add this together. Again, I would leave it as an improper fraction because this is going to make it easier to do the square root method. So square root, plus or minus the square root of negative 4/3, right? It's going to be imaginary. Take the square root of the top, that's going to be 2. Take the square root of the bottom, that's going to be root 3. And then you have to rationalize your denominator. So that's going to become 2 root 3 over 3. Then we stick the I in there. 2 root 3 over 3 with the I in there. When you write your final answer, you can write it the way I've written it here, or you can do something like this. Right? But make sure this 2 over here is not have does not have a denominator of 3, right? And I should write it a little bit better. 2 plus or minus 2 root 3 over 3i. And the I can be where I put it right now, or the I can be squeezed into this space here. Okay? Right, one last example I'd like you to try. This is the one that involves a fraction for the b value. So go ahead and pause the video and give it a try. Use completing the square method. So the answers here are x equals 0 and x equals 3. This is able to be solved by factoring, just GCF method. Oh, so quick. But practicing the square root method, there's no constant to add to the other side. That's okay. So we're going to set up our spaces. Right? And in that space, we have to take b divided by 2 and square it. So that would be negative 3 halves squared. I'm going to write it like that. On the other side, negative 3 halves squared, that's 9/4. Now, on the left-hand side, look how easy this is. Perfect square trinomial. It's x, and then it's that number that's in the parentheses, if we write it this way. Minus 3 halves, right? Our trick really paid off on this example. On the right-hand side, 0 plus 9/4 is 9/4. Square root both sides. Plus or minus, the square root of 9/4 is 3 halves. Just square root the top, square root the bottom. I'm going to move the negative 3 halves over to the other side. And then from here, your choice if you show work, 2 equations, 3 halves plus 3 halves, and 3 halves minus 3 halves. And that got me the 2 answers, 0 and 3. All right, guys, hopefully everything is clear to you. Go back and watch parts that you need again. And if you have questions, of course, make sure you bring them to class. All right, see you guys soon.